So today I'm going to share some of the research that we've been doing on rotavirus at the University of Minnesota, looking at the epidemiology that's happening in the United States, and then we went in and did another study, a retrospective study of looking at the sequences from rotavirus A strains from Canada. So rotaviruses, just a reminder what they are. They belong to the family Rotavirus. They're a double-stranded RNA virus. There are 11 segments. There's 9 tentative species. There's an I, but there's really 8 thus far that have been designated by the taxonomy group. Transmission is fecal-oral and also by fomites. And just a little bit about the nomenclature. They use a dual classification nomenclature similar to influenza. Influenza uses H and N nomenclature. We use GNP. GNP represents the 2 major outer glycoproteins of the virus. The VP7, represented in yellow here, and then the VP4, which is the spike that comes out as well. And if you're not aware of it, rotaviruses produces an enterotoxin that contributes to villus atrophy, and that's produced by the NSP4. So the groups, we only really care about rotavirus A, B, and C, so that's what we're going to be discussing in my presentation, and Laura will be talking about mostly A and C as we move forward. And previously we've done a study looking at the characterization of rotavirus species by different age groups. So we looked at neonatal pigs in the 1 to 3 day age group, moved on to suckling pigs in the 4 to 20 day age group, moved on to when the pigs are in the nurseries between 21 to 55 day age group, and then we also looked at greater than 55 day age. So just a reminder on some of that literature, we have seen that our neonatal pigs, we are seeing lots of rotavirus C infections in our diagnostic samples. This was a sample set approximately almost 2 years. As the piglets start to get a little bit older, we still see lots of rotavirus C represented by the green, and then we start to see an increase of rotavirus A as well. And then when we get into the 21 to 55 day age group, we see commingling of A, B, and C all together. This has been published many a time, or published once in a couple papers. If you want to pull that out, I can definitely get you a citation if you'd like. So we wanted to look at something a little bit different. We wanted to see if rotavirus infections were different by state, by the different regions that exist in the United States. We have the Midwest, we have South Central, and Southeastern. So we have a nice map here representing single rotavirus infection by A, B, or C. A represented in green, which is what we see predominantly in the Midwest region, Minnesota through Arkansas. Oddly, in our sample set, Michigan had a higher incidence of rotavirus B than the rotavirus A or C. And lastly, we have the South Central region here that has lots of rotavirus C infections. And Arizona, which has a small sample set, has a equal co-infection rate or co-detection rate of A and C. So just a little bit of different trends that are happening with rotavirus infections based on state. And then we start looking at co-infections that differ by state. So we want to look at rotavirus AB co-infection, rotavirus AC, and also rotavirus BC. So, and then all 3 together, ABC, and what we're seeing in our diagnostic samples that come to into the diagnostic lab. Minnesota, Wisconsin, and Texas. See, when we most likely test a diagnostic sample, it's going to be co-infected with all 3 of the rotavirus groups, whereas the states represented in blue have co-infections of rotavirus A and C, and then the red regions are co-infected with rotavirus B and C. So we're seeing a lot of co-infections in the state in Minnesota, some more down in Texas, but every state has a variation that's occurring in all these rotaviruses that are infecting in each of the farms. We did a little temporal distribution to see if they were fluctuating in prevalence over time. Basically, they're holding true. A is approximately about 70% were positive. Then it follows by rotavirus C, and then we see a rotavirus B. There looks like there's a seasonality trend in the data, but it wasn't significantly present, so we couldn't state any stats on that. And then lastly, we wanted to go in and do some mixed model effects to see if we can indicate what was happening, and it's different within state with rotavirus infections and also by different regions. So in this mixed model effect, we have fixed effects and we have random effects. So there's 5 different models that we ran statistically to see which one was best fit to the data set. First, we would keep age the same as a fixed model. We didn't include region in the model. We didn't include an interaction between age and region, and we did not include region and state. So we just kept on changing these parameters until we got one of the best models that had the lowest AIC score. Excuse me, the highest AIC score, which indicates that's the best fit for the model. So ultimately in our data set, or in our model, we had the fixed age. Region was not included. We did not include interaction, but we did include region and states as a random effect. So ultimately, what does this mean? It just states that rotavirus infections were more similar within states than between states and then between different regions. So if you're a swine vet in one state, say in Minnesota, and you're talking to your colleagues in North Carolina, you're talking about rotavirus infections, you might be experiencing different things within your herd. Most likely you are, and the stats just kind of prove that. Lastly, there's lots of things that vary within this data set, and especially in production systems, and some of that we considered as a variable within the region. So some of those region variables would be swine density. Some regions have higher swine density than others. Production systems, swine management. This was a change from all in and all out versus continuous flow, and also some of the weather that might be contributing to the changes in this data set or changing to how rotavirus infections are happening in each of the different states. So that was just a rework of a previous data set to see if we could get any more information out of it. And next we're going to move on to some work that a visiting scholar did on rotavirus immunity and epitope characterization. So again, rotavirus is a double-stranded RNA virus composed of two major glycoproteins. We have the BP7 and then the BP4, which is broken down into the BP8 and BP5. So in some previous literature, they looked at immunity and challenge studies to see how these G and P type interactions would protect against infection. So in this particular diagram, the BP7 is represented in red, and this would also be represented in yellow here, versus the BP4 is represented by the spikes. So these first two images are indicating if your BP7s are different and your BP4s are different, you're going to get diarrhea. So if there's no genotype similarity, you're going to get diarrhea. There's no cross-protection. You're just going to experience clinical disease. Versus if you were to have the BP4s represented by the spike match, but you have different BP7s, there was protection, but we're still seeing viral shedding that's occurring. Inversely, if the BP7s matched, but the BP4s were different, there was protection and there was no viral shedding. So this study was done now almost 10 years ago, and we had the sequencing data associated with each of the strains wasn't available. So we wanted to go in and see, okay, well, we know this information. We know there's a vaccine that's available for pigs, so we wanted to go look and see how are the current strains that are circulating in China, or excuse me, in Canada, compared to what's currently in the vaccine strain. So that's the Pro System RCE. It contains a G4, G5, and a G9, which is not on the label, and also a P6 and a P7 genotype. Also, there's the preventing against rotavirus infections. We see lots of feedback that's occurring, so we're going to go and work with our producers and see if the data set that I'm going to show matches what they're seeing in the clinical field. And then we also have some subunit vaccines that are available as well. So hopefully this information will help guide you guys on how to make better informed decisions, whether or not to use the vaccine for rotavirus A or even use the subunit vaccine, and how that might contribute to preventing piglet mortality due to rotavirus infections. So basically within this data set we had 32 historical sequences from Canada. We had one G3, G5, and G9. G3 is not currently in the rotavirus A vaccine. And the G5s were anywhere from 83 to 100% similar almost, and then within the G9s they're about 90 to 100% similar. So with rotaviruses and also with PRRS, we have been focused on looking at the nucleotide percent identity probably way too long. It's time to move more towards what influenza is doing and looking at some protein characterization so we can better understand the likelihood of protection that may occur with vaccines. So this is just a denogram showing the vaccine strain represented in blue versus the single Canadian strain, the G3, which is very different, of course, different genotypes. Within the G5s, the vaccine strain was in the upper part of the tree, and then the G5s represented from our data set are in red, and then anything else from Canada are in green. So they're dispersed throughout the tree. And then lastly, which is, I was looking at this last and it was intriguing, most of the strains that are circulating in Canada fall really close to the vaccine strain. And there's just one random strain that we were able to identify compared to the G5s where everything is away from the vaccine. So what does that look like when we start looking at the neutralizing epitopes? So for rotavirus A, there's three different neutralizing epitopes, 7.1a, 7.1b, and then 7.2. So this chart just has the vaccine strains represented in bold according to their corresponding genotype. Any differences in the vaccine strain would be represented in a color. So green is different from the G4 strain. The blue is different from the G5, whereas the red is different from the G9. So we just did a quick calculation of the number of differences. If you have a G3 strain, well, in this particular, compared to the vaccine, there was 13 to 16 different amino acid changes in the neutralizing epitopes. Versus if we look at the G5, compared to the G5 in the vaccine, this was 4 to 6. And then again, if the G9 compared to the G9 vaccine strain, it's 4 to 5. So, not sure what to make of that yet. I'm just going to put this out there and then move on to what we find with the P7s. If we look at that more on the protein structure and how the antibodies are actually seeing the proteins and seeing these differences within the G3s, there's lots of red. Red is just differences compared to the vaccine strain in the neutralizing epitopes versus the other colors represent the different epitopes. So lots of red. Likelihood of preventing infection, as previous studies have indicated, is going to be really, really low. Versus if we go to the G5, there's just a few spots represented in red. Something I did not inform you is that this protein itself is a trimer. So there's three different segments in here. There's one, there's two, and there's another one tucked in there. Versus the G9s, again, there's reds all over. So that's just a different way of looking at the data set versus just looking at strict up numbers to see a visualization of how the immune response may see a rotavirus infection. Now if we start to look at the P4s, again this is the segment of a P4, P genotypes. This is the VP5 represented by the stock and the VP8 represented by the two globular regions. Within genotype similarity of the P7s is anywhere from 90 to 100%. P13s had a little bit higher, about 94 to 95, and then the G9s were anywhere from 97 to 99. But how does that compare to the vaccine strain, again, that's circulating? Vaccine strains are represented in blue. They fall right here in the two strains. There's the P7s and the P6s. And so two of the strains here do not match closely. They're different genotype. Again, the red strains represent strains circulating from Canada, and they're kind of dispersed throughout the continent tree. We started to look at the number of differences between the circulating strains in Canada and the vaccine strains. Within the P7s, there's a P7 here and a P7 within the A2 strain. There's 2 to 4 differences. The P13s, this is where things start to get a little fishy now. You have a minimum of 14 differences all the way up to 21 differences. And if you go into the P19s, you have anywhere from 30 to 14 out to 22. So when we start to look at the genotype combinations that are circulating in Canada versus the vaccine strains, we start to look at the minimum number of differences that are occurring within the strains. So the P3 is a G3 P13 strain had 27 differences. So that probably is not going to have protection as indicated in the previous study done by Franco. So when we have a G and P types that match really closely, so there's a G5 in the vaccine strain and a P7, the number of differences was minimal. Now whether those number of differences are still going to allow protection, I don't know. We need some serological assays to follow that up to understand if there's still protection against these different serotypes to the vaccine strains. When we move into the P types that are not in the vaccine, then we start to see lots more changes. So anywhere from 22 to 25 for the P13s, G9s, and then for the G9s, P19s, we see anywhere to 18 to 19 differences. So ultimately, I don't have any good take-home messages, so that this is my main take-home message that's important. Sequencing allows us to investigate the genetic diversity And predicting the differences in the neutralizing epitopes may help us to better understand how rotaviruses are changing in the field. Vaccination rates for rotavirus A are really not known. At some point I'm going to go out there and try to get that information out of the industry and work with producers who are using the vaccine strains. Ultimately, these are predicted epitopes, and how the vaccine is protecting against these strains isn't known. And what we really need is good serological studies and serological assays to understand, is the traditional GNP type cross-protection immunity still accurate? Will there still be this cross-protective immunity that happens? And then lastly, this is all based on rotavirus A. We know none of this for rotavirus C. We don't know the neutralizing epitopes for rotavirus C. All the stuff that was done on rotavirus A is all because of all the research that's been done on human health. So luckily we're able to extrapolate from human health to figure out what's going on with rotavirus A. It's a completely different pathogen, probably has completely neutralizing epitopes, and it could completely stimulate the immune system differently, and Laura's going to present a little bit on that, what they're seeing in there.